On now with the variance of the return of a portfolio. Now it is time to speak about the variance of the return of a portfolio. Unfortunately, explaining the variance for a portfolio with more than two risky assets requires some more complicated mathematical tools whose knowledge goes beyond what is expected in this course. Hence, we will stick to the simple case of only two assets. We will denote the weights as usual, x1 for the first asset and x2 for the second one. And let us refer to the variance as sigma squared, with sub-index indicating the particular asset associated with it. We will also need in this computation the covariance between the two assets, which is denoted by sigma with two sub-indexes indicating the pair of assets 1 and 2. With these ingredients ready, the recipe for the computation of the variance of the return of a portfolio of two assets is given by the following expression. Let us explain it with the help of an example. Suppose that we put our investment wealth in only two assets. 2,000 are allocated on a stock, which return has a standard deviation of 0.25, and 8,000 are allocated to a bond whose return has a standard deviation of 0.12. Note that our investment wealth is thus 2,000 plus 8,000, 10,000. Finally, assume that the covariance between the return of the stock and the bond is equal to 0.01. Let me make a quick side comment here. Note that we use sigma to denote both standard deviation and covariance. The difference is that we use only one sub-index when we are talking about the standard deviation and two when we refer to the covariance. Back to our example. What is the variance of the return of our portfolio? The first term in the formula that gives the variance starts with the weight of the first asset. That weight, in our case, the weight of the stock, is equal to the proportion of our wealth to be invested in the stock, 2,000, over the total of 10,000. And this is 0.2. We square the weight and we multiply it by the variance of the return of the stock. The variance of the return of the stock, since we are given the standard deviation, is then the standard deviation raised to the second power, 0.25 squared. The second term in this sum of three terms that gives the variance is equal to the weight on the bond, which in this case is 0.8 then squared times the variance of the return of the bond. That is the standard deviation of that return, 0.12, raised to the second power. And finally, the third term in the formula is obtained by multiplying 2 by the two weights times the covariance. Adding the three terms, we get the variance of the return of a portfolio. As usual, we can also obtain the standard deviation by taking the square root of this variance, something that gives 0.1221 or 12.21% if expressed as that percentage. Let us look at another example. Suppose that now our portfolio involves the stock just as before with a similar position, but the bond is replaced by a risk-free asset. Looking at the formula again of the variance of two assets, we see that the second asset is risk-free, which means that its variance is equal to 0. Also, if you recall the details of the definition of the covariance and go back to the video presenting it if you need to, you will also see that its value in this case, since one of the two returns is constant, is equal to 0. So the value of the variance now simplifies enormously because two of the three terms in the formula are now 0. We just have to multiply the weight on the stock squared by the variance of its return. Now the weight is 2,000 over 10,000, that's 0.2, which squared then has to be multiplied by the variance of the return of the stock, given that value there. The standard deviation of the portfolio is, as usual, equal to the square root of the variance. That is 0.05 or 5%. We have learned with this example something quite interesting. In the particular case, when one of the two assets is risk-free, let us assume that the risk-free one is the second one, the variance of the return of the portfolio is equal to the weight of the first one raised to the second power times the variance of its return. The standard deviation is simply equal to the weight of this first asset, the only and risky one, times the standard deviation of its return. Final note is that if the weight on this first asset were to be negative, something that happens when we invest a negative amount in it, that is, we sell it, then we need to take the absolute value of the weight in the calculation of the standard deviation. And that is all for now. See you soon.